Okay, Dave, who do you have there?
Good morning. This is Cassian.
Oh my goodness, is
Hi,
she
Cassian.
adorable?
I'm doing a little babysitting while my wife and daughter drop a car off at the tire place. They'll be back in a minute.
Oh
So
wow,
say hello, Cassian. So I'm
Cassian,
Dave Schlichting. I am the Hunch mentor in the state of Colorado.
awesome. Cassian is a future Hunch student, I hope.
Yeah, how about that? What do you think? Yeah, he's nodding.
I'm I'm Gene Gordon. I'm a former mentor from New York. So
A very missed former mentor. And Glenn, you want to introduce yourself, please?
Oh, hi. I'm Glenn Johnson. I work at Johnson Space Center and I help put all these ideas and projects together.
Awesome. And now, team, would you each introduce yourself and tell us what grade you're in?
My name is Anna. I'm in 12th grade.
I'm Zafir. I'm also in 12th grade.
I'm Ollie. I'm also in 12th grade.
Awesome. That's really great. We are so glad you decided to do a project, and in particular, this project, because I think this project has real value even for the people on Earth to start using their trash, recycle it, do something so that we don't fill our oceans up with pollution and our landfills. So, all right. Well, I did give you permission to share your screen, so jump right in.
Good morning. We're a team working on the project Chess from Trash. My name is Ollie. This is Safira. Sorry, my name is Anna. This is Safira and Ollie. We're from Glenelg High School, and our teacher is Mr. Raymond Gershner.
Every year, approximately 18 cubic meters of trash is generated from astronauts in space. This roughly costs taxpayers $27.2 million annually. To resolve this issue, NASA is actively looking for ways to repurpose the trash that's already up there. One solution is to turn this trash into a game, which the astronauts can entertain themselves by making it, as well as making a collaborative and pleasant atmosphere playing those games with other astronauts as well.
Astronauts face two major problems with waste. One is the buildup of trash, and the second is its impact on safety and hygiene. Trash can reduce living space, spread bacteria, and also add mass to launches. At the same time, astronauts also experience confinement and isolation. Engaging activities like crafts, games, and challenges help maintain their mental health. This solution combines both these goals by turning trash into a creative and social game. Astronaut Greg Shimotov's article, Earth versus Space Chess, proves that social activities like chess can bridge the psychological gap between people on Earth and people in space. To find the best design approach, we researched several upcycled chess ideas. Our highest scoring one was a YouTube tutorial titled How to Make Chess at Home with Waste. It scored 27 points in total due to its accessibility and innovation. Our lowest scoring one was a DIY chessboard made from bottle caps. This is because of its lack of reusability and uniqueness. The overall trend is that the most successful designs use common waste items in creative ways.
After we felt we understood the space surrounding the stuff, we went into developing some concepts. So this first concept is a foldable board, which could fold down the middle and have chess pieces stored in it. That's pretty standard for mobile chess sets. This next one's a little more unconventional. It would be a plastic frame with cotton textile woven into strands between it, and then you would slide the pieces into knots in the rope. Here are two foam-based designs that we thought were really interesting. Uh, So we think that using foam rather than entirely plastic or aluminum or something like that is good because foam has natural shock absorbing properties to it, as well as it's not as commonly used and not as versatile as some of the other materials. So if we're cycling this material in addition to some of the other stuff, we're using stuff that couldn't be used for a better purpose. Here are some chess piece concepts. One of our first ideas was a nesting piece just to minimize the space that they take up when in storage. But we found it hard to design a locking mechanism for this. So we moved on to a more standard chess piece design with a locking mechanism, which we ended up going with for our final project. This would be a twisting piece that would collapse into a checker, but we thought it would be hard to do a number of variety pieces for this. And then this would be a pixelated chess piece, which has designed sort of like flat pack furniture, which would make it easy to assemble and print flat on the bed. After getting the design brief, we identified a number of concepts, both from the design brief directly and from what we thought we were capable of doing. So our number one priority we thought was safety, followed by things like size and being able to secure the chess pieces to the board. And then lower down, we've got some things like how much would the materials cost us on Earth, or how much would the design be visually unique. Here's a decision matrix of the concepts we showed earlier.
In our current CAD design, this can be divided up into several different parts. We first have the top part of the actual chessboard that would, for now, sits on the actual foam base. This foam base has like several different holes on the side for the chess legs to go into when snapped into the top. There's also some holes at the bottom for actual potential storage as well. The other part of this actual thing is the chess pieces themselves. The top of the board and the chess pieces we plan on making out of nylon or PTFE filament. And then the foam base we plan on using plastizoid. And then for the actual storage units, we plan on taking little aluminum cans and actually using that to store the pieces. With our mock-up, we made it out of Legos, nylon zip ties, nylon standoffs, and as well as little foam bits. The Legos is good for figuring out how a 12 by 12 area would fit. And then the nylon standoffs and the zip ties would actually be used to simulate how the chess pieces would theoretically work. And then we use little bits of foam to differentiate between the white and black pieces of the actual chess set. Along with our mock-up, we also printed out our CAD design. We cut out a little square and then also made our little pawn. The mock-up itself is like a square hole by 0.6 by 0.6 inches. The actual CAD is 0.5 inches by 0.5. We would prefer to use like a 0.5 considering we have thought about like actually shrinking down a little bit. So we need to go from 0.6 inches to then 0.5 inches, which is why that is 0.5 inches. And we also scaled down the chess pieces from normal ones. So we need to have little smaller holes in order to compensate for that. But we also took our chess pawn and scaled it up so then it could also fit into the mock-up as well, which is so you can see it's slightly bigger and fits into our mock-up as well as the one for the actual square hole. After like looking at our CAD, we decided we wanted to make some adjustments to it. This includes expanding the actual, well, not really expanding, but shrinking down the top of it so then we can have a little like bumper system on the sides to provide more protection to the actual chessboard. This would then have the actual square holes to be shrunken down as from like 0.6 inches to 0.5. And then we also decided to try and figure out how we would do multicolored, like different squares. It isn't shown up here, but we decided to like separate those individually and have them like slot together. This would then fit with the actual top being its little snap fits, and this would be a frame that would actually snap together, hold the actual little squares in place, and then would actually snap together and go through the foam as well to hold the top part, and then the top bottom part of the foam to gently hold it together and just make a cohesive all together one board that can also store everything, all the pieces and everything. For whatever we're going to do next, for what we're going to do next, we need to finish that CAD design. Unfortunately, it's still in development. We still have the build materials and we need to order those as well. As soon as we get those, we're going to start making our prototype, and we're going to make like 2 to 3. And then with that, we're going to collect quantitative and qualitative data, including absorption, force tests, and then actually have people play with it. And then based on all of this feedback, we're then going to iterate and revise our prototype.
Thank you so much for your time. We'd be happy to answer any questions, and you can view our process and progress on our website linked here.
Wow, that's pretty impressive work. And I want to say Nancy Hall has joined us. Hello, Nancy.
Hey, Flo.
Do you want to briefly tell us, just introduce yourself?
Oh, sure. My name is Nancy Hall. I work at the NASA Glenn Research Center, which is in Cleveland, Ohio. I'm a project scientist, and my main focus had been on fluid physics. And recently, I'm helping out with the Mars Campaign Office. They have a whole bunch of tech demo, and one of the ones we're looking at is sending a mini X-ray up to the space station for testing to be part of the list of equipments they'll be using on future missions. So that's just a new job I'm doing now this year.
Well, we are so glad you're also a hunch mentor for us. So thank you so much. All right. Let's start. Who wants to start?
I've got a set of questions that I'd like to follow up on. I find your design really compelling. It's quite an interesting approach. With that, you said you'd like to do this in a nylon, correct?
Yes.
So do you have any information or evidence on the recyclability of nylon in the environment where our astronauts are going to be as a useful material?
Not currently, no. We know nylon's recyclable, and we looked at the material list and the allowed list of materials, and we figured that nylon was the best material for this application.
Yeah. And I encourage you to continue to pursue that. Obviously, one of the challenges that we have with this project is we don't really have a complete list of the types of plastics that NASA would be using. And therefore we're kind of creating analogs, right? We've got a lot of teams that have kind of focused on the idea of water bottles and milk cartons and things of that nature. Of course, another challenge is the recyclability in most schools. There are difficulties there, but I would encourage you to continue doing as much research as you can to establish the viability of, again, recycling a nylon and having it, have the kind of properties that it's going to hold up in this type of an environment. So for the prototype that you've created, you have a clipping mechanism there, and you printed that out of what plastic?
This is printed out of PLA filament.
Okay, so and PLA is probably a pretty good analog. So I would encourage you, among other things, to do as much testing as you can, just snapping these pieces in, pulling them out, repeating this over and over and over again, because it's a question mark just how resilient PLA is going to be with that type of thing. My concern is it's going to break. And, that's just simply, you have to test and get the data on. But, it looks pretty promising. Now, I have a couple of suggestions for you. First of all, I suspect that most of the plastic that would be used on a surface habitat would probably recycle into something that ends up being kind of grayish, right? One of the challenges we're dealing with that we don't really know is we want this to be not monochromatic, but that's going to be problematic, right? We may end up printing a whole lot of stuff that's essentially the same color. So I would encourage you to think about ways of indicating the squares on your board so that you can have something that delineates a black square from a white square. And one of the questions that I've asked students to think about is, can blind people play chess? And the answer is yes, they absolutely can. They're using tactile signals to tell them what's going on here. And you might be able to implement something like that into the design of that board. Do you kind of get where I'm going with that? Because I think that realistically, it's going to be a challenge to produce something in multiple colors, right? So that would be a 2%er. That could be a real advantage here. If we can't make, reds and greens or blacks and whites, etc., what can we do to make it possible to differentiate the pieces that are being held, one set of pieces versus the other on the board, etc. Okay? So that's one consideration. And I
Hey,
just
Dave,
had Glenn, go
are
ahead.
you suggesting we're going to be sending blind astronauts to the moon?
Well, maybe someday, but I think more realistically, it's just a
You
matter
never
of
know.
how do you differentiate one set of pieces and pieces on the board, right?
Right.
So that's a possibility. Another suggestion would be this. Irrespective of what material you print your final prototype out of, what I would do to emphasize the utility is determine the total mass of plastic that you used, right? And then gather up enough pieces of plastic waste. Again, it could be water bottles or anything, and create kind of a pile out of this and take a photograph and have that part of your presentation to say, this is how much material we can incorporate into this board. Pictures are worth 1,000 words, and it's persuasive because, again, as you pointed out, we're going to be generating a lot of waste. And what we want to do is repurpose, upscale, whatever. And this is a way to just kind of emphasize this is how much plastic it took to make this board. Okay?
Yeah,
All
that's a
right.
very good idea. Thank you.
I'll let somebody else chime in here now.
Well, go ahead, Gene. Gene's our chess player, so
I'm a gamer. I don't chess is just one of the games. I several things I wanted to point out. I really like the fact that you went through the various ideas of nesting and twisting
yeah.
and things like that as you and figuring out how this board is going to work and how they're going to stay in place. The whole idea is cool, but I'm going to side with Dave here. Is that you need to really spend some time analyzing and testing your snap-in idea. Okay? Not that it's wrong. I want you to understand that. I think it's a very cool idea. There are various shapes and things you could use to relieve some of the stress on there that will be in place. But definitely do some long-term testing of putting these things in and out of the holes. Okay. I really, I think that's where you want to go with that. I like also when you're doing this, Dave's idea of the colors. Going to the idea, thinking about especially chess. Checkers is a little bit more. I'm thinking of games that are on the board, the chess board, but chess really gives a feel for an aesthetic, and going with an aesthetic that instead of going with colors, maybe you use a texture on the outside of your features, basically the same shapes for kings and queens and things like that, but a different aesthetic on the outside, a different texture is actually a cool idea to think about, and it sets yours apart from others that way. Um, the nylon, interesting idea. Again, more research there. But then again, we're trying to make it out of trash. So the more things you can use from trash, I think that is a cool idea. So definitely continue along that. But I think you did it's obvious you did a lot of research and testing right now, and I can't wait to see what you do in the future here.
Awesome. Thank you. Glenn, you're up.
Hey, I really like. I noticed that one of your materials you mentioned plastizote. I think that's a great idea. I think that we're going to have lots of plastizote, and I think you were using that for part of the board. Is that correct? I think that's a smart idea. Anywhere where you can have a mixture of 3D printing and just trash, where you're modifying the trash, I think that's a terrific idea. Um, Now, one thought for you, your chess pieces look you're still using the same kind of styles, and I think there's value to that. But I've been spreading around a couple of thoughts. For example, you're when you're on the moon, you might be thinking about things at home. And so could you change the style of your pieces by being, for example, let's say ocean creatures versus um, African Serengeti animals, right? Or thinking about like, okay, this one's kind of funny. Imagine if it was your family versus the other family, because your Uncle Joe and Aunt May are way cooler and more powerful than their Aunt Millie and Uncle Robert. You know what I mean? And so by having family versus family, you could personalize each of your chess pieces for the people that are on the moon or something like that. So I like what you're doing with this. I think this is really smart. Oh, one question for you in terms of so I've taken a piece now, or I've captured a piece. Where do you plan to put it? It looks like you have some space underneath, but I don't see how you put them underneath.
We will have aluminum cans underneath where you can store all the pieces once you're done playing, and you can also put your captured pieces, and that'll be inserted into the foam. So
Are they
that
slots? So like drawers, do they slide in and out, or how do you do that?
they like down.
That sounds good. Um, I like it. I could see it a little bit from the side there. So I can't wait to see how you guys put that all together. Terrific ideas, team.
Yeah. Nancy, are you still there? I see Doctor Who's.
Yeah, I'm still here.
Awesome.
I was meeting with another group, so we were putting different backgrounds there, so I forgot.
Oh, that's awesome.
Yeah, I just came in at the tail end, so I don't have any comments. But
Okay.
I'm still here.
Okay, thank you. Could you stop sharing and show us your pieces? Because I know you had some pieces to show us.
Absolutely. So this is the size we think we're going to use for the actual end product. This is the larger size that works with our mock-up.
Oh, look at that.
That's Lego.
I love how you did your first demo with it. I think that's very smart. Good
Can you
job.
hold that up?
I want to see the board again. Oh, nice.
So do me a favor, clip that in there and now turn it over. There you go. There you go. Proof positive. I like
Good job.
I think that's dynamite.
Nice. Very nice.
We wanted to get an idea for how big 12 by 12 really was.
So,
important.
A separate question: who's the best chess player on your team?
Probably me.
And
I expected all three hands would go up, but
and this is curious from a gamer type of point of view. Is like, could your idea for what you're planning here be used to create pieces for other games and other boards? And that's an important idea when you think about it. Not all boards have just a single piece you can stick in and things like that. So,
We actually had some ideas for both Catan and Scrabble.
mhm.
Cool.
Okay,
Cool.
Very
That's
cool.
neat.
Very nice.
Hey, can you hold your board up one more time? Um, so you have that configured, 8 by 8. Okay. Um, so think about this for a minute. You're designing this for a surface habitat. And although the gravity is weak, it still exists. It's not a requirement that everything stay contained. But if, for instance, this same game board were to be taken onto a spacecraft and it's now going to be played in microgravity, where are you going to put the pieces after they've been captured?
Um, as we have aluminum cans at the bottom and they will be secured at the bottom once we actually build it. And that's where you'll put the captured pieces. You can probably turn it around and either put the pieces within, or we can design a more secure holding area for them.
Great answer. So you've already anticipated that. Good for you. That's a great way to think about it. Okay. Thank you.
Awesome. Do you have any questions for us? Okay, you can always ask questions, send the email to me and copy your teacher. And if I don't know the answer, I have a whole team here that can help you with that answer. But actually, I am a lover of the chess game. I think that I used to teach math, and I thought that I would have them play chess because I thought it would help them to understand math. You have to think ahead and plan ahead, and math also. So thank you so much.
Why did you guys choose this project over the others?
We did a kind of majority vote where we each listed 3 projects we were interested in, and Chess from Trash was within all of our lists. I thought it was a very fun idea. I was like, this is very creative and not something you usually see in an engineering class. But I was like, might as well. This is a fun project.
Very good.
Yeah.
We also thought it played to our strengths because both Koi and Saphira are very artistic.
Uh-huh.
Cool.
I like that.
And
Is
personal,
Thank you, team. Excellent job.
yeah.
personal
Really
question
cool.
from my point of view. I've only been gone from Hunch for 2 years, but I've seen some faces in this group. Have I met you guys before? Have you guys been in Hunch class before?
No, I don't
No?
think so. You
Oh.
might have met my sibling.
Yeah, that's
Okay.
what I was thinking. It's siblings. Mr.
Okay.
Gershner has siblings all the times, so that
No, I
could
didn't
be
know.
it.
When I ran a class, we had students that were every year, so for 4 years, so I could very possibly have met you before. So, okay, thank you.
Yeah, no, thank you so much. That's awesome. I do have one question. Did you, on your research, you found people using trash on Earth to make chessboards?
Yes.
That is so awesome. That's so that's an application of your work that you can add that to it, because if we can make it in space, we definitely could use the trash here on Earth too. That's cool. Great job researching.
Besides chess, are any of you gamers? Do you play a lot of other games?
Yeah.
What kind of games do you like to play?
Usually online, but I'm a big fan of cards and like Monopoly, yelling at my friend.
Strategy board games.
Okay.
Also, usually video games, and also like a few card games as well, like Taco Cat as an example.
Yes.
Taco Cat,
Strategy
cool.
board games, tabletop games.
So
But
if you were going to the moon, what kind of other games might you be interested in?
I definitely like to bring a pack of cards just because there's like so many different games you can play and like such
Like
a
that?
variation.
I'd want to bring games that have a lot of replay value, but something that's not like going to get people particularly heated. So maybe something like Catan, Scrabble, Ticket to Ride, something that's a little more casual Euro game, as opposed to like Monopoly. I think would be a bad choice just because it can drive up so much anger. But something with like a lot of options, a lot of mastery, so a game that's harder could also be good.
I think Ticket to Ride might have a few too many pieces to.
Yeah.
But Glenn is asking this because I convinced him to go to a conference this past summer that he's now considering getting into gaming. So.
Well, the other thing that's important is that we have people, including teachers, that do simulations for going to the moon and Mars, and what kind of games do they need for those demonstrations as well. And so chess is one that there's so many people that understand chess. But of course, we really need to start thinking about that broader version of what kind of games would be helpful. And multiplayer rather than just two-player games would be really critical. I mean, four-person or even six-person games might be important. So anyways, team, I think you've done a great job. Thank you so much for sharing. What do you think you want to do as your next prototype?
We have our next prototype. We do a mock-up and then a prototype once we get the actual materials in. So we want to do a mock-up first that uses sort of analogous materials, PLA and some different foam that's not plastic soaked properly, just to see how like it would look. And then once we can order the materials, we want to make a version using the actual materials to see if like there's any unexpected interactions that are going to come up, and just do the actual testing. Like, does this absorb water even though we're not expecting it to? Is this actually really brittle and we need to use like support structures?
Very good. Excellent job, team. We probably need to get going on to the next team, but thank you so much for sharing.
Thank you. And have a wonderful afternoon. Great work, guys and gals.
So much.
Bye-bye. So actually the next team is Tri-County, and they're on, and they've been listening the whole time, which is good. So they know what we have been covering. So let's see if Tri-County wants to come on. Thank you, Glenelg. That was awesome. Miss Magnus, is your team ready? That we're early. Yes.
Hi there. Hi, yeah, we are just about ready. We have a student laptop set up here and it's being a little weird with its connection, so I'm setting up another one just in case this one.
But we see and hear you really well right now.
Yeah, everything's fine.
Yeah.
Okay, wonderful. Well then let's go. Thanks for being here.
Thank you.
Oh, let me get in frame.
Oh, good. So did you hear the introduction of the people who are listening in today, or did you come a little later?
Oh, no, we did not hear.
Okay, so want to briefly, Glenn, you start and introduce yourself?
Hi, team. I'm Glenn Johnson. I'm at Johnson Space Center, and I help get all these ideas put together and set them up so that you guys can work on different projects.
I thought you were going to say so you guys could have fun. Yes. All right, Gene, you're next.
I'm Gene Gordon. I used to be a Hunch mentor and left about 2 years ago. Just in here, just because I can't leave Hunch alone.
And he's a gamer. So thank you for joining. Dave.
Good morning, everybody, or good afternoon, maybe where you are. I'm Dave Schlichting. I am the mentor for the state of Colorado, and I collaborate with Glenn on all of these projects and work with teams all over the country.
Awesome.
Glad to meet you.
Thank you so much. And Nancy.
Hi, I'm Nancy Hall. I'm actually the regional mentor for schools near the Nassau Glen Research Center, which is in Ohio. So I have teams in Ohio, Minnesota, Michigan, Missouri, and Wisconsin, and portions of New York. So looking forward to hearing what you guys have done.
We're glad to have you back, Nancy. Okay, so now team, introduce yourselves and you can share your screen whenever you're ready.
We're just gonna share our presentation right now.
Okay, and is it okay I'm recording this?
Yep.
Yes.
Okay, thank you.
Do you have any trouble on that? This one's
How?
It's already.
Okay, can you guys see that?
Yes.
Yes.
So our presentation is Chess from Trash. This is our preliminary design review. This is by Jocelyn Wahlberg, Zachary McCarthy, and me, which is Savannah Sharoff. And our instructor is Christian Magnus, and our school is Tri-County in Franklin, Mass.
Okay, so my name is Jocelyn Wahlberg. I'm the project manager, corresponder, and the secondary editor for our team.
I'm Savannah Sharoff. I'm the note taker, purchaser, lead prototyper, and lead researcher.
Hi, I'm Zach McCarthy. I'm the editor, scheduler, and lead CAD.
So NASA asked us to convert material that would otherwise be considered trash and form it into a chessboard, which could be used by astronauts. And to provide a solution to this problem, we will create a chessboard made out of the recycled materials and make sure that the board can function in microgravity and the lunar surface, and also make sure that we follow the major criteria of our customer, which they've outlined. So to start off our research, we reviewed the HUNCH resources that we had available, which was the HUNCH Design and Prototype website, which was made by Glenn Johnson. And we also reviewed the conference with Lisa, which was also a part of the website. From the website, we understood that we had to make our board out of recycled material, which wouldn't readily kind of contain magnets or Velcro. We also need a 12 by 12 size constraint, which is just because we don't want a really small chessboard or kind of a life scale chess piece, because it's not really practical to kind of play with, especially in kind of the closed habitats that they might have. We also understood that it might be kind of an advantage to secure our pieces to the board, especially when dealing with different types of gravity. Our board should also be waterproof and cleaned easily, just to prevent mold and bacteria, and also just to kind of wipe off the oils from your hands that you might transfer to the pieces when you're playing with it. And we can't have off gas at all because it's basically toxic fumes that are pose a very dangerous health risk. And we also can't have flammability because we don't want, our product bursting up into flames in a habitat, or especially like on a different planet. That would be a very dangerous situation. And our board should also be very durable because we don't want it to break and create a hazard for the user or injure them in any way. We also want to incorporate 2 different colors just to be from traditional chess, just to be able to tell the pieces apart. And then from the conference, we learned that the autoclave could be used just to kind of sense off gas a little bit, where it exposes it to high temperature and high pressure, and we would just sniff it after it's kind of gone through the cycle. And it's not that effective, but it's still better than having no test at all for off gas. We also understood that super glue could also pose a hazard and would be very dangerous to kind of incorporate with our design, as well as unprofessional. And we also gathered that molds can be used, which would be very interesting, where we can take any recycled material that we want and form it into the pieces that we want to make.
So microgravity is the environment in the orbit, and this affects our project because ours has to survive gravity, no gravity, and microgravity, as the chess pieces could float away if not secured correctly.
So we also need to consider the needs of our customer when we're designing this board. And we think that one of their priorities is a source of entertainment, where they might think of chess as kind of a relaxation, or again, just a source of entertainment for them. And they also want a solution where they can recycle trash that might be building up in their habitat. And as long as what I've said before, they feel more at home because they might have a connection with chess to Earth or one of their favorite pastimes, and they might want to also have that in the lunar environment or in their habitat. Chess can also provide mental exercise and critical thinking, which are necessary skills for astronauts to have.
Mhm.
Our board should also be lightweight and compactable just for ease of use because you don't want a heavy weighted piece, especially because it might cause strain when you're trying to move the pieces around, as well as have the board to be safe and non-toxic just for the safety of our customer.
So some of our design priorities, number one is recycled material. This is most important because this is the whole point of our project is to make a chessboard out of recycled materials. The second most important is no off-gassing or flammability because this could be a big safety risk. The third one is secure attachment. This is important because the chess piece could be flying projectiles if not attached in microgravity. The fourth one is durability. This is important since the pieces should not break during playtime and broken pieces could be a hazard. Number five is compactability. The size of the board is important as well because a chessboard shouldn't be too small or too large to maintain the quality and ease of moving the pieces. It should also be waterproof and easily cleaned because you don't want any harmful bacteria to grow on it. And they also need to have style and color so you can differentiate the teams.
So our final pathway, after conducting research on 3D printing and recycled materials, we decided that we wouldn't go down that route and we would instead direct our board and pieces directly by fabricating boards and pieces from recycled materials and different items that we might find. We decided to eliminate 3D printing from our solution ideas due to the high risk of off-gas and additional processes or equipment that might be necessary to craft recycled filament. For our research, we found out that the refabricator was used on the International Space Station, which was a way for astronauts to recycle broken tools that they had and just reprint them with the 3D printer, which would limit resupply missions. We also reached out to some recycled filament companies, which we had Eco 3D Print, and we did try to reach out, but we didn't really get a response from them. We also reached out to Filamentive, which was another company that we found the entire process to which we would need to use to make the recycled filament, which would be shredding, drying, extruding, and then winding it. By using recycled materials, we think that there are more creative solutions that can be developed as opposed to making just a CAD model or just a 3D model of what you want the board to be. Overall, after researching the recycled 3D printing process, our group decided that it was better to rule it out and focus on what we can create physically by using available trash. So to start off our ideas, we decided on a paper process which it would involve cutting paper into strips in like kind of a vertical way and then dunking them into kind of a cup of water and then forming them or wrapping them around themselves to make pieces. So in the left image, you'll see a pawn and an attempt at a knight.
Another idea that we came up with was sewing from either dirty clothes or old clothing, as they don't really have a way of cleaning clothes up in space so far. And this is a way to reuse all that stuff. And we found that sewing is a good method of calmness and to calm the mind as well, and really helps with stress that is going on as well.
So this idea we had was also weaving packaging from MRAs or different type of plastics they'd have in their food containers on the space station. And basically we would weave packaging and put bottle caps as an attachment method and basically put the chess pieces on the top of the bottle cap and unscrew it to move your piece. But this also may be a problem because we have to make sure that it's very tightly weaved together.
So this is another idea that we came up with blister packs. This was actually used, we found these in our shop from an earlier Hunch project from last year. And we found two ways that we could use this in our project. We could use it as a way of connection with the board and the piece, as shown on the far left image. And then we also found a way that we could use it as a mold for the paper processes or just any of the other materials that we might use.
So following along with the MRE material, we understood that the board that we used for weaving might not be readily available in different environments with their food packaging. So we just weaved the plastic with itself instead of being on the board and heat sealed it together. The problem with this design is that there could be off gas, but we have to test for it, especially with the heating and sealing process. And as a form of attachment, we decided to make a prototype with one of our paper pieces, and we used some of the plastic from the MRE food packaging, and we twisted a knot at the bottom of it, and then we would make a slot on the cardboard board right there, and then just insert it in, and it's actually very durable, and we threw the whole like cardboard that it was on all around, and it stayed on.
So this is our matrix system, the decision matrix, and we decided to make it into three different parts where the one is attaching, one is pieces, and the one is a board. So then we can find the best fit for each as we can incorporate every single way into one project, as we could pick a way for the pieces, which could also work with any of the boards or attachments. So we decided to choose that way of separating it to keep our ideas nice and clean and organized as well.
So for the pieces, I believe we showed you most of our options, but we had the paper form pieces as well as the blister pack molds that we were thinking about and fabric pieces. And through, rating them on durability, safety, off gas, and also kind of the accessibility of the materials or how easy it would be for astronauts to craft, we found that the molds are relatively good for the pieces. And we haven't made any final decisions with any of these matrices, but it's just giving us an idea on which one of our ideas might be better to follow through with. And then for the board, we had the melted heat sealed food packaging, fabric, and also the weaving into the food board and recycled paper. And for that matrix, we decided that the weaving into the food board was the most effective, but there are still some problems with that design, so we need to kind of figure that out before we run with the final design. And for attaching, we figured out that we could just sew the pieces into the board, which may be kind of a difficult process. And we also thought about using bottle cap tops, where we could twist the cap into the piece that is inside the board. We also thought of backpack clips, which would be more of a 3D printing solution, but as previously stated, we kind of ruled that out. We also experimented with the ribbon of plastic knot on the bottom of the piece, and we did some tests with that and found out that it was pretty effective, as well as blister packs as an attachment method, which we found was one of the best ones. So overall, just the theme is that we think that the blister packs are proving their kind of worth to our project, and we might incorporate it with our final design.
So some of the ways we're going to test for some things are we are going to test for durability by dropping the product from 3 feet and test to see if any pieces fall off. We also have to test for off-gassing, which we can use the autoclave for that, and we can smell it and make sure there's no any like toxic fumes or anything like that. We also have to test for attachment by shaking the chessboard and making sure none of the pieces fall off. We also have to test for cleanliness, which we do by taking apart the chessboard to clean it, and we should test if there's any bacteria growth on it. And one last way we have to test is by user input. So we're going to have somebody test it and then ask them how their experience was.
So our next steps, we start with the prototyping. We want to combine our different solutions and develop the prototyping design as we use the decision matrix with our top ones to combine them and see if they work best and try to assemble a fully usable board because we haven't made one yet. Right now, we made individual pieces and attachments and all that, but we haven't created a board yet.
And then following our next steps in the testing department, we want to test attaching throughout the entire board with our different methods, as well as incorporating, again, what Savannah said, a full board and just trying our best to assemble that. As well as testing our blister pack molds more, since with the matrices, we've found out that they might be an effective solution for us. So we want to test more into that and kind of mold with other materials, because for the original test, we just used our paper process. And along with that, we want to make sure that we can have a prototype and make sure that we test it properly.
Another next step, we do have to do a little bit more research on off-gassing produced by the heat seal, as we said before, because we only tested it once and we want to try again to see how effective this could be and how safe it will be, as well as if sewing needles are safe in space, because most of the research that we still need to find is if some of our ideas are safe or not.
So following our research, we'd also like to reach out to some experts that we know of. So the first expert that we want to talk about is Word Lily, who's the company owner is Tita Iganiski, and she makes paper products. So in the left image on the kind of bottom right there, you'll see paper. It's kind of a book, and then the front cover is recycled paper foley, and she kind of sprinkles botanicals in there. And that's where we really got our first inspiration from, because personally, I bought one of her cards from a shop, and then I kind of realized that we could make recycled paper pieces. And then that's how we followed through with that idea. And we'd also like to reach out to Ocean Soul, where they're a company that picks up flip-flops from beaches and makes them into these beautiful sculptures. And we think it's very interesting because they've also made a chessboard out of the flip-flops. And we want to reach out more to them about their process with that.
So some questions from us is, what is the availability of bottle caps? So how many bottle caps do they produce up in space? And is sewing done during missions in space at all? So has this happened before in space? And is food packaging like MREs used in the space station?
Great questions and great original creative ideas. I love what you presented just now. That was really awesome. So thank you so much. Actually, I do have some of the food packaging, and some of it is MREs, at least that we send to the space station right now. And to the space station, it's only about $10,000 a pound. But when we go to the moon, it's going to be $1.2 million a kilogram, which is about 2.2 pounds. So the price of it, I don't think we're going to send any MREs, but I'll need other people's opinions on that. And I'm kind of going first here, guys. For the sewing, so no sharp objects on the space station, at least, because they're in microgravity. However, I need you to look up finger knitting on the Hunch Academy website. We have a video from a past it was a past project that we had making lunar art without bringing anything up. And they actually use old clothing, like you suggested, but they use their fingers to knit it together. So that is a big possibility. You'll have to ask the others if sharp needles are allowed. I don't think so, but I'm not an expert on that. And bottle caps is another issue. So right now, we don't, when we send up food or a drink even, which I have here, that's the kind of cap that's on it, not 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 a bottle cap, but we send up medicines, I think, with bottle caps. So let's hear the maybe we'll start with Nancy. Nancy, do you know any more information about those questions?
Not about the bottle caps unless it's something else. You brought up a good point about the needles, and I know there's different types of caps and covers, so you could look at different ones there. I also do have some questions on their presentation. Can I do that, or do you want to go
Sure.
through?
No,
Okay.
go right ahead.
So one comment you made, I thought it was neat how you did your analysis and you looked at off gassing with 3D printing. One thing I do want to mention, because we have worked there, it's not just the fact that the material off gas, but also how much. So, like you mentioned, you thought you would use 3D printing. If you use 3D printing, say for a small bracket, that wouldn't off gas as much as how if you were to bring, say, 300 brackets. So when we do our testing on off gassing, and we do it like you do, we put it in a chamber, heat it up, see how much it releases. We're told how many of this sample could we bring in before it becomes a problem. So we had this little module, and they told us we could send up 5,000 of these before it becomes an issue from off gassing. So I really like the idea of you using the blister packs and everything, but I'm going to say don't give up on 3D printing. If you just want to make one small item and 3D print it as part, that should be okay, because the amount of off gassing from a small part, because remember, we also have a 3D printer up there, and it's in, I believe it's in the glove box. So there is a way for it to capture the off gassing and send those out into space. So yeah, using recyclable materials is fine, but I just don't want you to eliminate 3D printing if it's just a small part that you think you need. But other than that, I like the idea that you mentioned about chessboard made out of flip-flops. That would be neat to see. So those are mainly my comments.
Thank you. Dave, how about you?
Well, first of all, I have to say, I find your approach in your presentation really compelling. This idea of molding and using paper is something that thus far I've not seen anybody else do. And I'm working with a lot of teams right now. So I think that you may have tapped into something that is unique and distinguishing to yourself. I would also say, and one of the things that struck me with your idea of moistening paper and molding and creating shapes, um, as someone who does a lot of woodworking, and things of that nature, I'm kind of, I'm kind of artistic that way. I know there are a lot of astronauts are as well. And I think that would tap into a level of creativity that could also result in other things, right? I mean, what we're doing right now for Marshall Spaceflight is kind of a beta test. This is a project where we're demonstrating the capability of, creative ideas for recycling. There are a lot of things that astronauts could make or do with this type of stuff. So I find this very compelling, and I encourage you to keep going in that direction, right? I like what you've got here. I'm very anxious to see, your first iteration of this. And to that end, your teacher has all our contact information. Feel free after this, once you get something assembled, to send something out to us. I'm just really impressed with what you're doing. Um, as Nancy said, we can 3D print, but there are a lot of 3D print chessboards right now. Stay with something that it has some uniqueness and creativity to it.
Mhm. Continue with that artist. That was
Absolutely.
really great
Absolutely.
reaching out to her,
Yeah.
and getting her involved. That because we even had a project. I'm sure everyone remembers lunar art. So this could do both, recycle trash and bring lunar art to the astronauts on the
Well,
moon.
let Gene chime in here because that was his
Yeah,
idea in the first place.
I know.
Well, if you want me to go next, I can.
Yeah, sure, Gene, go for it.
I gotta say, I wrote down with 3 exclamation marks your idea of the blister pack. Recycling and using materials that have no other use is a great way to go with this project. I have been a proponent, as everybody said, of using the material, using the garbage or anything that we don't use, or we want to, we're going to throw out for other things. So the idea not only as the mount for the chessboard, but I saw the one you had stacked together and stuff like that to make pieces. That's brilliant. It's a great creative use of stuff that we're going to throw out. And and like Dave just said, the idea that the astronauts get to play around with this, and it could help out their mental states, and this is wonderful thinking. The You're sewing, putting the sewing in this. There, by the way, Flo, it was the astronaut Karen Nyberg who did the quilting in space. And she did have sewing needles and everything up in space. So sewing, I think sewing pieces is a wonderful idea. It'll use small amounts of cloth, and you could Dave's idea in the last project was how do you get color involved?
So
Materials. You could the materials, the cloth that are up there could be wonderful for that. So I really want to give you kudos on the idea that you're thinking away from the 3D printing. 3D printing is getting people use it to solve too many problems and not thinking around other things that they could use. So great job.
Awesome. Thank you, Dave. And Glenn. Is Glenn here?
Well, I'm glad Gene brought up Karen Nyberg. You can watch her video of her trying to sew on orbit, which is difficult, but because we'll be on the moon, I think it'll solve
Easier.
some of those issues. MREs, they won't send up the big packet like what you have pictured there, but they will have smaller packets where it's the single item. Whether it's the beef stroganoff or the spaghetti or whatever, that'll be there. In terms of the plastic caps, right now, I don't think that they're going to be sending up plastic bottles. Flo's comment about on the caps on the pill bottles, that might be accurate, and I think that's actually a really good thought. However, one of the things that's difficult here is NASA does not send up things to space that are very recyclable. And that's one of the things that if NASA wants us to recycle things, then you have to choose some materials that will be able to be recycled. So it's something that NASA has to choose about, and the things that you're suggesting here are all reasonable. So I think it's very smart. The other thing, I really liked your idea of using paper, get it wet, compress it into the mold. I think that's really smart. And imagine if you 3D print your mold, now you can press that paper product in there and you can get whatever kind of shape that you want out of that paper. I think you guys have some terrific ideas here. Excellent job, team. Um, and, and the way you were weaving the plastics together, I thought that was also really smart. Now, we say 12-inch by 12-inch. That's our maximum size we want to see, but I don't say anything about the height. And so if you guys want to work on places to be able to place your chess pieces or whatever, that's also an option. Okay. Excellent job, team. Very good.
Yes. Do you have any other questions for us now that we reviewed these questions for you?
We do have some our prototypes here with us if you guys want a closer look at those.
We do.
Love to
So
see that.
stop sharing, and then we'll be able to see you.
Hey team, one final comment. I've asked a lot of teams working on this project how the materials are going to be stored. And the options are, well, you could, since the pieces conceivably are going to be attachable to the board, you could just leave it set up. I'm not sure that that's actually the most viable thing. So I want you to also give some thought to how you're going to contain these pieces and be able to store them. And to that end, there are a lot of chessboards that kind of fold up like a book. The pieces kind of fill inside, etc. That's one approach. But regardless of whether we're on a surface habitat or a spacecraft, space is a very important commodity. It's not like you can just, you want to condense this down as much as you can, right? So think about ergonomics as well. If you're going to pack your pieces together, how can you do it and make it the smallest possible storage volume you can? Just a thought for you to consider, okay? Now let's see your prototypes.
So this is the packaging that we weaved together tightly,
Wow.
kind of with like a back brace on it.
And then we also have a fabric piece, which we kind of made a little face on it, just for like creativity, because we were really having fun with the sewing thing. As what you guys have said, it's a very nice pastime, and it's just kind of a simple little pillow thing. And then I think we have the most prototypes of our paper stuff. So this is the one that I mentioned before, where it's attached to the board by that plastic piece. If you can see the plastic.
Can you flip that up a little bit so we can see the underside better? Okay. Okay.
So what was that trash?
The attachment is going to be a thing you need to do here. How to cloth or the paper is really.
Because this is just kind of a rough thing to see if that would actually work, but we need to develop more on that completely.
Yeah, okay. What is that green thing at the bottom?
That's a piece of emery plastic.
Oh, plastic. Okay.
From one of the food packaging, yeah.
Okay. Oh, and by the way, the food coloring, on that lunar art project, I remember one team used leftover food. If they have beets, and they do have beets and different food colorings that you could use for your coloring of your paper. And I wonder if that person who you have contact with, she even uses food coloring for her projects.
Yeah, we definitely want to hear more from her, because I know some of her pieces, she actually has glitter in it, which could offer some color, but I don't know about like kind of
food,
how that works.
Yeah.
And then we also have, this is supposed to be a pawn, but it's paper, it's all paper, and it's actually considerably hard, where we just left it out to dry for a few hours. And then these are the other ones that we have, the little smaller ones.
Awesome.
Cool. And then this is our little blister pack mold that we have. And then you can just pop it right out, and it's still in the shape.
So you said those blister packs were from last year's project. What project was it last year? Do you know?
I think
that was one of Allie's projects, the packaging of.
Yeah, I think it was for medicine packaging.
Yeah, that's what I was thinking too. So we might have stuff like that, actually. That's pretty cool. Good. All right. Well, thank you so much. That I love the thinking outside the box. That is really cool. And I hope all of our comments have helped you. And you can reach out to me anytime, that's for sure. Just copy your teacher, but we all would be very interested in how it advances, and we appreciate your work on that. All right, you have a wonderful afternoon. We have another school, I hope, that is ready, even though we're way early. That's in Bozeman, Montana, Bozeman High School.
Excellent.
Carl.
I was very impressed. Lots
Yeah.
of original ideas there.
Yes,
they were.
Agreed.
excellent. Carl, are your students around?
They're waving.
Yeah,
I
looks
see
like
'em.
we're here.
Hey guys, how's it
Awesome.
going?
Hello.
And have you been listening to our presentations?
Just this last one.
Okay, but you heard the introduction of our reviewers?
No, did not. Didn't catch
Oh,
the introduction.
okay. Tri-County, I gotta unpin them. Hold on a second, because I had them pinned. Because I'm recording this. Is it all right if I record you guys?
Yes,
Of course.
that's okay.
Okay, I want to pin you. Okay, and I want to unpin them. I can't seem to unpin them. Remove pin. There we go. I got you live. Large screen. Awesome. All right, then I need you to introduce yourselves, and you can share your screen if you have a PowerPoint presentation.
Yeah, working on that just right now. Should be, yeah, just screen two. And then
Thank you for coming early.
And then slideshow on the upper right.
Okay.
And then you'll just, let's minimize this screen so that you can see.
Minimize this.
Yeah, I don't know why this is.
We see you. We see your presentation. It's
there you go. Just keep on. They're just like these.
PowerPoint's up.
Yeah.
Okay, well, I'm Graham Rowland, and
I'm Brennan Blakesley.
we're doing the Chats from Trash. So, you guys obviously know this project because you guys created it, but so kind of the overview of the project is you guys wanted us to create a chess set that could be made from waste materials on the lunar base. That would either be like a 3D printed chess set or a thing made from just waste materials, straight from waste materials. And we wanted to do the 3D printed one. So some of the constraints for ours were low gravity, which meant that the chess pieces could not just sit on top of the board. They had to be attached to it without glue or anything. And the print space, that was a limited factor. You had a 6x6 area to make a 12x12 board. And so that kind of reduced the stability of the board in general. And then obviously weight and space reduction, you had to keep the weight and space down to decrease the cost of sending up the materials you might need. And off-gassing, you had to make sure that whatever product you in the end created, it did not off-gas.
Some problems that we had were securing the chess pieces to the board because of the low gravity. It's really hard to just keep them on the board. Like if you bump into them, you can't have them fall off. It was way trickier than we expected initially. We tried to modify the bases of the chess pieces. We thought that it would help them stay in place, but the real solution came when we shifted our focus to using the tiles on the board as connectors. The friction fit approach worked much better, and the pieces stayed securely in place. Another problem that we had was keeping the chess pieces recognizable. We needed to create pieces that were not only functional but easily recognizable as their chess counterparts. It's always tricky because you want to balance creativity with clarity. And we eventually opted for minimalist designs that maintain the integrity of the chess pieces but weren't overly complex. Another problem that we had was printing in an area smaller than the board. We needed to create pieces that were not, never mind, printing in an area smaller than the board. Because the printer can only 3D print a 12 by 12 at max.
Or 6 by 6.
Yeah, 6 by 6. It was, we have to make the board in 4 separate sections and we have to somehow interconnect them. Yeah. And solutions. First, we use a friction fit to secure the pieces in the board instead of adding the complex connectors. We made sure the base of each piece would fit snugly into the holes of the board. This way, the pieces would stay put even in the low gravity environments, but they can also be easily removed, shown by the example there. We also modularized the board. Since our 3D printer has limited space, we broke the chessboard into smaller sections that could be printed individually. Each section could be snapped together with pins, and this allowed us to print a 12 by 12 board in smaller, manageable chunks. For coloring the pieces in the board, we'll use like a colored cloth. The squares of the chessboard are filled with fabric pieces, which added color. The chess pieces themselves are also wrapped in cloth, creating a unique aesthetic while still being easy to differentiate. Lastly, we focused on weight reduction. We added indents to the pieces and the board to reduce the amount of filament required to make the pieces.
For some of our earlier designs, we used screws and stuff we used screws on the bottom of the pieces to connect that to the board, and we didn't have any difference between the board was just one piece instead of multiple. That was and we changed that because we couldn't change the color of the pieces if it was all just one section. So we had to print in a lot of different sections. Kind of back up in here, you can or down here, you can see how we in the end changed it so that each piece is lifted or is printed separately from the base of the board. And then for the board sections, some of our earlier designs folded into each other, kind of like we heard you say book a while ago, folded like a book. And yeah, they folded like a book, but that proved to be a bit too complicated, and it was a bit too complicated to 3D print all as one section. So
here's a look at our final design. You can see the modular board that snaps together using pins. Each section can be printed separately, and the fabric squares fit neatly into the board to create the chessboard layout. As seen, the pins are inside connecting the chessboard. The pieces are simple but functional. As I mentioned before, they're each wrapped in a cloth to differentiate them clearly. We've also made sure that each piece fits securely under the board through its friction fit design. The approach allowed us to create a chess set that's both lightweight and sustainable while still being fun to play with.
So then, in conclusion, our project does well. You asked us to create a chess set that used materials from the moon that would have otherwise just been thrown away, and use those as something that the astronauts did not have to just throw away. And we do think that our project does fulfill those requirements. It does at least not waste all the materials that they have. We didn't really use all the materials that we had access to, but we're still working on that bit.
Okay. So do you guys have prototypes to show us?
We have some online prototypes. We don't yet have a physical prototype.
Okay. Yeah, just see if you can show us some of those. You said online. Is that something you can share with us on the screen there?
If this shares, yes.
Yeah, so the green border
that's working.
So.
Okay, so this is kind of what we have for the board in general right now.
And I like that. I like how you've got the different colors represented there. Um, and so how do you think you're going to be able to print how do you expect to be able to print the I mean, here you see three colors. Do you have thoughts on that?
So for the colors on this are only printed or they're only shown as the three different colors to differentiate them. But
Sure.
like we kind of mentioned, we're going to use a cloth in between these holes here. So you've got this bit and then the actual piece, and
Oh,
that will differentiate the color between the pieces.
now I understand. That's terrific. Thank you so much.
Yeah, no problem. And yeah, if you guys have any other questions, feel free to ask.
Let me clarify. You're going to have a layer of cloth sandwiched in there as well?
Yes, just in between this. Yeah, just in between here.
That's cool. I like that. You've done a great job of coming up with a way to add color to this. Hey,
Yeah.
Glenn, this is a question that maybe you can answer that might be helpful. I had a team ask the other day. We've constrained the obviously the print plate 6x6. Do we know what the maximum height on those machines is?
Right. Let's assume that it's not going to be any greater than 6 inches. So 6 by 6 by 6.
Okay.
Yeah.
Okay. Yeah. So that I obviously, guys, that's not going to impact yours because you're not making, 7 foot tall chess pieces or 7 inch tall chess pieces. But
Now,
that's
so
also a consideration there.
now one of the other things I was just jotting down is we say that we want two colors, but is there any reason why they can't have more colors than two? And I couldn't come up with a reason. What do you guys think?
I mean,
Absolutely not.
yeah,
So
for coloring the pieces, we were going to use the cloth, kind of the same cloth that we were going to use on the under the board, and we
yeah,
were going to use that kind of as a clothing. So, I mean, I guess if you wanted to, you could change the clothing color rather than the base color.
That's
that'd be funny. Make
guys,
so
that's
little
really
little
interesting. I
t-shirts.
like that.
Yeah.
I have two questions about that actually. The have you tried building this and testing that with the cloth?
Not quite yet. It was kind of my fault. I didn't really think about printing this out before we did this presentation, which is my fault. But
Well, I'm not trying to suggest that you build the whole thing out here. Like building just one square
yeah,
with one
Yeah.
and testing it out. But the other question was, how do you plan on attaching the cloth to the plastic? Are you thinking glue? What are you thinking?
well, I mean, with these, when you press these down on these pins, it's very snug. It's a very snug fit. So once,
Yeah.
and then with the cloth, it should be even more snug, and it'll just hold the cloth in that way. Just
So
That's
the
I like
so
that.
I just want to make sure I understand this. So the cloth would be represented like kind of like the circle in the middle.
uh, it's not
If you
really.
put if
Yeah,
you pin the
yeah,
cloth down over it.
yeah.
And so what happens when you put the piece on top? Does the color of that square get covered up?
The color of the square doesn't. The color of the square doesn't really matter. I mean, yeah, on this at least, these are just the representations of what the colors would be.
Right.
So the cloth goes in this hole. This is whatever single color it needs to be, and then the cloth is what actually represents the color. But I mean, if that answers your question, I'm not really sure.
Okay. Well, the reason I'm thinking about this is like I like your idea. Don't I'm not
Mhm.
trying to think negatively about it. I want you to think through this. Is that let's say you put your 32 pieces or was it 16? Yeah, 32 pieces on the board, and they're in, let's say random positions around there. You see the colors of the squares as the circles, but everywhere but where the pieces are, because the pieces are going to be covering those circles up. Does that make sense?
Yes, yes, that makes more sense now. Yes.
Okay, so that's what. So when you're thinking about the color of the square, because you're looking at a chessboard, you're seeing the black, white, or whatever colors the alternate the two colors. So think about that while you're considering the cloth. Like, how do you put the cloth in there to make sure that you see colors not only of the pieces but of the squares, no matter where they are.
Yeah. Okay.
Does that make sense?
Yes, that's making sense.
Okay.
And I have a question. I like how you have them set up in 4 different groups. Is your plan to ship them up separately so it's like a smaller package, and then once it's up there, they'll connect it? I was wondering if that was the reason for because I really like that.
I mean, we intended on this being 3D printed at the lunar base, but
Okay.
That's correct.
Yeah.
Nancy, the
But I'm
issue is
wondering
the print size can't exceed 6 by 6 inches.
Yep.
Okay.
So a large board is going to have to be assembled by multiple pieces.
Okay. Well, I just like how it was put in that area because it just looks like when they're done, if they want to put it away, they could take it and just stack it and stuff. So, okay.
Right.
Yeah, I like that.
So guys, point of clarification. The pieces that the individual chess pieces are going to, do they kind of rotate when you set them down? Do you rotate them in and then they clip into or do a friction fit into those 4 corners?
Yeah, it's
okay. All right.
See what this is doing. It's
got
on
it.
the edge of these
Totally.
pieces. There's
Absolutely.
clips, and then this just slides down right onto that.
Okay. So now, so a couple of thoughts. Gene mentioned, and I think it's a good idea. Print just one square and one piece, and you want to test that repeatedly, right? You want to make sure, and obviously, whenever you're printing, tolerances are critical. You want that to be right, but depending upon the kind of plastic you're using, if there's a snap to this at all, that plastic can get fatigued and it may break. So you want to test that a lot, and I recommend just doing one piece in one square rather than printing out a whole big section of this.
Yeah.
Because if you realize after a little bit of testing that you've got to go back and do some modifications and stuff, you don't need to waste all that material.
Those are all great comments. Going back to the part that is black and white on your model there. Yeah, the black and white squares. Are those each individually printed, or is the 4x4 one piece?
So this 4x4 is one piece.
Right. What about the top, the black and white ones?
But then these things are each individual. But I mean,
They
you can
are.
probably print one of these or
Right.
like 4 of these in one section.
Right. So that's what Dave's suggestion is really good. Print one of them and print a piece and test it. Keep going in and out of it.
A lot, over and over and over. That's one of the concerns that, with this, just how resilient. And again, a question is, if this is recycled plastic, does it lose any of its properties with each kind of heating and extrusion that you're doing? So I would test it a lot.
Yeah, okay.
And obviously keep track of how many clicks you actually perform.
But I really like the design. It's very unique, and also pay attention to Gene's suggestion that when you have a piece in there, you're not going to see the cloth under it. So that would make chess a little more challenging to not know if it's on a black or white piece. So if there's a way to do that, that would be good.
Flo, to kind of go with these guys though, to me that's a subjective consideration. When you're playing a game like this, you put you put a piece down, whether it's checkers or chess or whatever, you still see some of the color of that square. Now, if the piece is going to cover that cloth and you've lost the color,
Mhm.
how much of an issue is that? So what I would do, guys, is ask a number of people to try this out.
Mhm.
And one of the things that you can assess is that a distraction or is that a deterrent in any way or not? You
Mhm.
know, we shouldn't just assume that's going to be a problem. That's a testable consideration. And I
Yeah.
like testing. So get some people to try it.
Yeah, because you can figure out what color it is by the color next to it,
Yeah.
right? So
Guys,
it would be a little more challenging, I think, but it would be interesting.
okay.
And you can figure that out for sure. So
Guys, have you given thought to the style of the pieces that you want to have for the players?
I mean, right now we have something really, really basic, like there we go.
Okay. Yeah.
They're just all pretty basic pieces, nothing incredibly unique, but
Well, and that's okay.
yeah.
One, I think that there's a focus on the part of a lot of teams to kind of embellish the pieces, to do something creative with them. And early on, there was kind of an overwhelming sense of we're going to make pieces that have a space theme to them.
Mhm.
And there's certainly nothing wrong with that. But, from my perspective, I've asked kids, why do you play a game? It's a way to, go into your own world and think about things that, it's kind of escapist, right? So if you're an astronaut and you're living in an enclosed habitat on the moon, do you need to be reminded of space? Maybe not. Maybe doing something that kind of gives them a distraction and thinks of something completely different. Now, I'm not trying to sway you one way or another, but there's nothing wrong with just trying to be creative and unique. Okay?
Yeah.
Yeah. And actually being cool looking. Like your pieces are kind of cool looking. I like that. Have you considered the material? Is it 3D printed recycled material that you're using or
Yeah, I actually have a few questions about that.
sure.
So, the filament that they're going to have up there, is it going to be recycled plastic, like just recycled plastic, or are they going to have actual 3D filaments?
So our interest is for them to be able to recycle the material up there. And so we have a few teams that are recycling their plastic. And so they're making a recycler, but we determined that that's awfully expensive and difficult. So we're not expecting you to do the recycling, but the astronauts on the moon, they will be doing the recycling there to some extent. Does that make sense?
Yes, that makes sense.
And just to follow up on that, guys, the impetus behind this project comes from Marshall Space Flight, where they're creating a mock-up, a training mock-up of a surface habitat. And one of the things they want to do is to find feasible ways to recycle a lot of the material that is going to the moon. It costs, as Flo pointed out, it costs a lot of money to send things to the moon. We don't want to just take a whole bunch of mass and turn it into waste somewhere, right? So the spirit of this project is based on we want to be recycling stuff.
Yeah.
Other thoughts, guys?
So is that your 3D printed material? Are you using any that's been recycled or what material are you using?
Right now, we've got this, which is a recycled 3D filament. We're
Oh,
gonna be
you
using this
did.
for all of our prototypes and stuff once we start doing them.
So you purchased recycled 3D filament.
Yep.
Yep.
That's awesome.
That's great,
really
guys.
cool.
That's great.
Yeah. Okay. Any other question do you have for us?
Well, actually, no. I guess that question was already solved. So the other question I had.
Yeah, because I didn't really get the chance to read your questions that were at the end of your PowerPoint. You had a question or two.
Yeah, it was just two, but you already answered both of them. So thank you.
Okay. Okay, good. All right. You can always send questions. We're here to help you. If I can't answer it, I got a whole team here. But make sure you copy your teacher on that. And you guys have a wonderful afternoon. How's the weather there in Bozeman?
It's been pretty nice the past few days. Looking like it's gonna start snowing soon, but
Well, that's good.
So why did you guys choose to do the chess from trash project?
I mean, I think we just both play chess, so
Who's the better chess player?
probably Brennan, yeah.
Okay. I like to play chess, but I don't pretend like I'm great at it, right? So I suspect that you two would both beat me, but that's okay.
We're both like pretty terrible, but like
Yeah.
I'm a better terrible.
Well, that will
And
be
that's
fun.
okay, too.
That will be fun to be able to play chess with your board eventually. So very nice. Thank you so much.
job.
That's
Thank
awesome.
you.
That's really cool. Okay, we have 9 minutes until the next team comes.
But there's a team on already.
Are they on? This one is in New Jersey. Oh, they're here.
Yeah.
Yes, awesome. Well, we're ready for you if you want to present, unless you guys need a break. My mentors, do you need a break? Or can we? We're going to have a break after this one.
Well, if we got a few, why don't we take a break for just a minute? And that
Okay.
way we can,
Yeah, you got some time there for 11 o'clock. So take a break for what, a few minutes.
just a minute or two. We'll get back.
Yeah. That's good. Unpin you guys.
Hey Flo, got a quick
Yeah.
question for you. If you can update I updated my calendar, so I should be able to meet with the team on Friday.
Chris's, I know he sent me an
Yes.
email back, but I
Yep.
haven't looked at it yet.
Okay. Yeah, he said his team will present at 9:45. I just need to know. Yeah, I
That's
like how
Eastern time. He's
Yes.
he's in New York.
Yeah. I like how today you have the times everyone is meeting. So that was real good.
Yeah, because they're different schools all over the country.
Yeah. So okay. Yeah,
And
I should be
we
on this
have-
afternoon.
Yeah, we have Cortland at 1 o'clock your time. No,
Yep.
2 o'clock your
2
time.
o'clock. Yes, I'll be there for Cortland at 2. So that should be
Okay, that's awesome. Thank you so
Yes.
much.
good. Okay, no problem. All right.
It's really fun seeing you. So thank you.
Well, it's fun. It's great to be back.
Awesome. Hi, Nick.
Hi, Flo. How are you?
Good. Well, we've been doing this all morning, so we're just taking a little break. They're coming back. We've got some really good mentors on that, and I put it all online. So I'll send everybody the link, but it's on the NASA Hunch YouTube so that you can see all the kids. They don't even have to take notes because they can watch it online. And just make sure, and I think all of your kids have, you have done the Reg Pack. Perfect. So that gave me permission to put them online. That's awesome. Do you have any questions before we get started? Because this is your Well, you did it last year too, right? Second year.
This is our second year. Yep.
Yeah, that's cool. So great. Um, yeah, you're the last team until 2 o'clock your time. So
Sounds good. Listen, save your voice. I know you've been on all day, so you don't have to talk to me. You can just take your break. Take your break.
I let the mentors do the talking here. I don't have to talk, and the teams do the talking. I hardly have talked, actually, right, Glenn?
Okay.
I haven't talked very much.
Not that much. No, that's good.
Okay. Well, Nancy left, but she's coming on for her team at Cortland.
Well, no, I'm still here. Yeah,
Oh,
I'm
you're
gonna
still
listen
here?
to this. Yeah, I'm still here. I can listen to this team, and
Oh,
then
awesome.
I'll be back for Cortland. Yep.
I love your Doctor Who thing. All right. So what time is it? Are we ready, guys? We have a few minutes. 4 minutes. We'll wait till 11. I like this project. It's I'm glad they picked chess.
We like it too.
It's my favorite game, actually. I'm not a gamer, Gene, but I
you could be.
Yeah, you could be.
Maybe if I retired, I could be.
If you had gone to the conference I got Glenn to go to this year, you'd be a gamer.
Oh, you would be so impressed. There were some great ideas for how to use games to get more people involved in whether it was science or history or all kinds of. Oh my God, they were great games.
Yeah, it's really cool. So
yeah, I'd like to see more of that happen in classes. I was very impressed.
Yeah. Okay, Dave, are you ready too? Nancy's on.
Yes,
Dave.
I am.
Okay, so we're ready when you are. This is Bergen County in New Jersey. Actually, right near New York.
Yes, we're very close to New York.
It was fun visiting with you.
It was great meeting you.
You too. I'm so pleased. So did you hear the introduction to our mentors? Did you hear who's online? No? So
no, they just
okay. So everyone want to introduce yourselves?
Sure.
Glenn.
Hi, everybody. I'm Glenn Johnson. I'm at Johnson Space Center in Houston, and I coordinate with all these other people to help come up with some of the best ideas that you guys get to work on.
Awesome. Nancy?
Hi, I'm Nancy Hall. I'm the regional mentor for our schools near the NASA Glenn Research Center. I'm located in Cleveland, Ohio. So I have teams in Michigan, Missouri, Wisconsin, Minnesota, and Ohio, and portions of New York. And I also help Flo out with her other schools too.
Wow, that's awesome. Glad to have you. And Dave, our wonderful mentor from Colorado, my neighbor.
Yeah. Good afternoon, Dave Schlichting. I am the NASA Hunch mentor for Colorado, and I just want to mention Glenn's being a little humble. He runs this program, so I collaborate with Glenn on a lot of these projects, but he's the person in charge.
Very important person in charge. But our mentors are vital too. So thank you, Dave. And we have our gamer, Gene.
I'm Gene Gordon. I'm the former New York State Hunch mentor. I left a couple years ago, but Hunch doesn't get out of your blood. And as I've mentioned, I'm very pro game and education, and former teacher and still a gamer. So I like the idea of using all different types of things to make games. So I'll let you go.
So very impressive group of mentors. Thank you all so much. And team, would you please introduce yourselves too? Uh-oh, you're muted. Don't look so worried.
Are we? Can you hear us now?
Yes, yes.
Okay, thank you. We are the Chess from Trash team from Bergen County Technical Schools, Teterboro. I'm Caitlin Zhang.
I'm Shiloh Hong.
Sebastian.
Awesome. Nice to meet you again.
Nice to meet you
Nice to
too.
meet you.
So our problem statement is that NASA astronauts accumulate trash in space and that take up a lot of space in their limited spacecraft. So we are trying to repurpose this trash into a chessboard. This is the general design process that we followed that we will cover throughout this presentation.
So these are just some of the general requirements and constraints. Some of the most important are the board size, which will be 12 by 12 because we are not using 3D printed filament. It must survive a drop of 3 feet. It must be waterproof, and it cannot off-gas during production. Those are the main ones that we focused on. So here are some of the research topics we did in preparation before we started designing anything. It focuses a lot on recycling, such as recycling plastics, papers. We also focused on off-gassing because we wanted to make sure that we did not cause that at any point.
Okay, so here we have the existing design decision matrix. So what this is, it's like it's what we used in order to so basically we first got ideas from the web, and you could see our sources on the right, and then we would like put them into this decision matrix, and we had a few specifications like manufacturing complexity, manufacturing time, and cost. And based on a scale of 1 to 5, then we rank them, and then from that, then we got to see which ideas we would pick. Oh. And this is the creative design decision matrix. So this is based off of our own ideas, and we use the same specifications and we rank them as well.
So after that, we decided to take some of the ideas that were in the matrix and sketch them. So these are my sketches. I had the finger knitted board from recycled t-shirts. The pieces utilize flexible metals like aluminum, and we went for a floral theme for this one. The pieces would have hooks on the bottom of the pieces to hook into the weaving to make sure that they did not float away or anything like that during gameplay.
So here was my idea. I had like a space theme for the pieces. Like you could see like for example, like the rook has like a star in the middle of it, and also for the chessboard, I was thinking of making it of a soft material such as foam, and also that the squares could possibly be glued on and be of a different material, and of course the white and black squares would be different colors.
My idea was using a cardboard as the board part, but I still wanted to include the finger knitted idea with the recycled t-shirts. So at first I came up with a sort of hand knitted bag for the chessboard and the pieces to encapsulate all of them. But for the board specifically, I thought of cardboard to make sure that the board sticks in space without floating so it can survive zero gravity. I thought of adding suction cups to the bottom. And in order for the pieces to stay on, we thought of using bottle rims where we'd cut off bottles and put a rim on each sort of square so that we can twist the pieces on and off. And the theme I came up with, the pieces were engineering versus engineering, where aerospace has space shuttles from NASA and Artemis and other identifying components, where the electrical engineering team could have different pieces of a breadboard with resistors and capacitors. Overall, we decided that our theme should be plant pieces because there's not a lot of plants and flowers in space. And for the board, we thought that foam with plastizo would be our best option. And the fastening portion for the chess pieces themselves, we thought the bottle caps was the best idea. And to the right are the materials we end up gathering.
Okay, so here we had our finalized concepts, sketches, and and like materials. And here, these are like our ideas, but like we didn't have like all the available materials. Sorry. And here we have on the top, then you could see that there's a chessboard, and it would be made out of plastizo foam, and it would have been glued with suction cups in order to prevent it from like floating around in space. And there would also be bottle rims, like where the squares are, in order to pass into pieces so that they don't float around in space. And on the bottom, then there's a chessboard case that would have been finger knitted.
So I designed half of the chess pieces, the king, the queen, and the bishop. The king would be an iris because those symbolize royalty, and the overall shape looks quite like a king chess piece. The queen is Queen Anne's lace because the namesake, and it also shares the shape of a queen chess piece. And the bishop is a tulip because they both have the tapered, rounded top.
I drew the other pieces where the knight would be the lily of the valley. And since this is one of our more complicated pieces, I sort of broke them up into the different materials we've used, such as fabric and wire. The next is rook being a sunflower. And we have a lot of pawns on the chessboard, so we picked a simple sprout for that option.
So this is our first prototype. We will be remaking everything shown here using the information we got from this. But basically, the point was to just see what kind of methodology it would take to create this, especially these three pieces. It is the knight, the bishop, and the queen, because these were the most technically diverse and difficult to pull off. So we wanted to make sure that we knew what we were doing. In terms of the bottle caps, we can demonstrate here by removing the queen and the bishop by twisting them off and then swapping their positions. In the real thing, yes?
Could you stop sharing there so that we can see that a little bit better?
Yes. Okay. So here's the pieces, and you can see twist them off.
And it's just a quarter turn to take it off and to put it back on, isn't it?
You can twist it however much you like.
Yeah. No, I think that's great.
It's wonderful.
Thank you.
Thank you.
Yeah, thank you so much for listening.
That's really terrific, team. I think that you've got some really nice stuff. You know, it's funny. I was looking at the pictures. I was thinking, how are they going to make that? And then you showed us that little bit of artwork with some wire and was that cloth that gave you the color? What did you use there?
Yes. So the orange is the cloth of a t-shirt, and then this is
cling wrap.
Yeah, cling wrap, pink cling wrap.
I think that's terrific. Great job, team.
And then, and what did you make the board out of? Yeah, I think I missed that. What was the board?
Okay, so the board is made out of foam with the top being a plastizo form for the different colors. So it's it's a little thinner.
Okay.
Nice.
I have to say the idea of using a floral pattern for the pieces is brilliant. It's one of the things that people in space, one of the things they miss are color and nature and things like that. And that is a wonderful, wonderful idea. And I really like the bottle top. It's a nice, simple connection.
Yes, so actually you would have to have instructions that the astronaut could follow to imitate what you are designing there. But then with the material that you're laying out for them, they could pick and make their own designs for their pieces.
Yes.
So it's really creative and artwork on top of using the trash to make a chess game.
Thank you.
Really cool.
I like it a lot. And you came up with some good ideas for some different flowers and things like that. But you also struggled with a couple of others. How did you decide that you wanted plants as opposed to you know, mechanical engineer versus electrical engineer, which is really funny.
So we were deciding between them for what the main idea we had was to pick the plants because in space there aren't a lot of plants there, and also to make the technical pieces that we drew would have been a little complicated with the trash that was available to us.
It's a very smart choice. And I also see that with a little bit more creativity, you could say plants versus animals or plants versus something else. So I think you guys have a really great idea here. Excellent job, team.
Thank you.
Along those lines, just the idea that you're using things like the electronics, old discarded electronics and things like that, which there will be a bunch of when things fail, is wonderful. Well thought out is probably the best way to say it. It's, stop saying wonderful. Just say it shows that you've done a lot of thinking about this, and the psychology of gaming is important so that you're making them be more personable. And each person gets to have their own set, maybe. So that's kind of cool.
Have you made your bag yet?
No.
Oh, you haven't? Okay.
I love you using finger knitting. I love that you're using finger knitting. That's cool too. But that would be really cool. And everybody could have their own set of chess pieces and make their own, whatever they want to be, which is adds another dynamic to the game. I'm a little worried that we might not have enough bottle caps from the
That is the concern, but you're bringing up a good point, Flo. Do we have enough caps to be able to do this? But the other thing is, there's so many other things that we don't know that are going to fly yet.
Yeah.
That I think that there's a good possibility for what they're suggesting, at least.
Yeah. I think for medicine, we at least have that type of cap, not,
I think so too.
And it's real easy to turn on and off, which is really cool. And I like the suction cups. You got to be aware of the outgassing of the glue, because you said you were going to glue the suction cups to the board.
Yeah, what kind of glue are you thinking you might have available?
Right. So we decided against hot glue because of the off-gassing problem.
Sure.
In our space, we have tacky glue, which is very effective for what we're trying to do. And it does not produce off-gassing as far as I'm aware.
I'm not familiar with tacky glue.
Okay, yeah, okay.
It's a common crafting glue.
Oh, is it? Okay.
Isn't that what we use on the walls? They put it on to hold a picture on the wall or something.
And I know that we've sent. Oh, okay. Is it kind of like Elmer's glue? Or?
Stronger.
It's a variation of that. It's used for fabrics mostly.
Oh, okay. And because I know that we've sent Elmer's glue to the space station one time, but so I think that's a great idea. Good thinking, team.
Thank you.
Thank you. That's good. Do you have any questions for us?
I don't believe so. Thank you.
Okay, you can always email me. And if I don't know the answer, I have a whole team here that can help us, which is awesome. So, but copy your teacher. That would be important.
So. Why did you choose to do this project?
Well, I personally really like the idea of design. I myself am very artistic, and also the whole challenge of having different resources was very interesting and kind of tantalizing to try and figure out.
I also think that I'm a very hands-on person. So when I found out about this idea, I really wanted to try, especially since chess is a very like intellectually challenging game. So I thought it'd be really interesting, especially because with the finger knitting, I really like to crochet. So I thought of it as sort of crocheting without a hook.
And how about you? What were you thinking about?
I feel like I like the design portion a lot, and also like I like playing chess, so that definitely factored a lot.
So who's the best chess player on your team here?
Haven't tested that yet.
Okay. All right. I'm very excited about your project. I think you guys are doing a terrific job. Thank you so much.
Yeah,
Thank
and
you.
thank you so much, and you have a wonderful afternoon. And don't forget, if you have any questions, just let us know. But I love that you brought art into this project, which is cool.
Thank you.
Okay, and mentors, we have a break until Cortland, which is a new school. Bye bye, Bergen County.
Thank you. Have a nice day.
Thank
Thank you,
you so
Jane.
much. Enjoy the afternoon. You did a great job.
You too. Thank you.
Um,